Hey everybody, I am recording this video in the dark outside in my backyard in front of my fire, and I gotta say, this is my favorite way to record videos. So maybe after this, I'll have a s'more. How's it going? Hopefully you can see me now. I am backlit by a fire. This is pretty cool. So while I'm near this fire, I'm going to talk to you about planes in space. And what's funny is a plane just flew overhead and it kind of looked like it was outer space because there were stars behind it. I'm going to have fun with this one. So let's talk about planes in space here. The last video you watched was about lines in space. I always say in space. Lines in space. And what you needed to remember about that is there wasn't an equation for a line in space. It was a set of equations, a set of parametric equations. When you get a plane in space, it's one equation, uno singular, okay? The equation of a plane is built off of the vector and a point on the plane. Now, the way I said that was kind of a misnomer. The vector is not on the plane. The point is, but the vector is not. A plane is defined by its normal vector. Because if you think about a plane, there are an infinite number of vectors lying in the plane. But what we do is we use what's called the normal vector, and that's the vector that's perpendicular to it. And that's going to be a unique vector. So planes are defined by their perpendicular vector. All right. The standard form for a plane, you put the vector as your coefficient, you subtract your points, and you set it equal to 0. And then if you want to distribute A, B, and C and get your constant on the right-hand side, that's the standard form or general form. I don't care which one you use. I am happy with both as long as they are equivalent. So the coefficients come from the normal vector of the plane, and the initial point goes in the parentheses. So write the equation of a plane normal to the vector 2, -7, 8, and passing through the point 5, -1, 0. So the coefficients are 2, -7, and 8. The plane is set equal to 0. Don't forget your equal sign, okay? And then my starting point is 5, -1, 0. X minus 5, y plus 1, z minus 0. So there's your plane. You can just leave it like that, or you could say, well, that's going to be 2x minus 10 minus 7y minus 7 plus 8z equals 0, which is 2x minus 7y plus 8z equals 17. And any of those forms is okay by me. All right. Write both forms of the equation of a plane passing through the points 3, 1, 4, 2, 5, -6, 1, 11, 17. Okay, they didn't give me much. They gave me the point, but I do not know anything about a vector that's perpendicular to this. But wait, perpendicular vectors. I get perpendicular vectors from cross products. So if I can make some cross products out of these 3 points, I'm good to go. Because if I think of a plane and it has these 3 points on them, let's call them A, B, and C. If I cross AB and AC, I will get vector n that is perpendicular to that plane. So let's do it. Let's call these A, B, and C. And let's create a cross product. So AB would be the vector -1, 4, -10. AC would be the vector -2, 10, 13. And my normal vector n, I'm going to call it n, is going to come from the cross product of those two vectors. 1, 4, 10, 2, 10, 13. So it's going to be I times, what's that going to be? 52 minus -100, so 52 plus 100. Okay, wow, that's big. So 152 next to the I minus j times -13 minus 12, which is going to be -25, plus k times -10 plus 8 is -2, which gives me the vector 152, 25, -2. All right, I can deal with that. And then I just need to create the plane. Fine, I can do that. I've got my normal vector. So my plane would be 152 x minus 3 plus 25 y minus 1 minus 2 z minus 4 equals 0. And then if I distribute that, holy baloney, that's going to be 152x minus 456 plus 25y minus 25 minus 2z plus 8 equals 0. So that's 152x plus 25y minus 2z equals, all right, so 456 plus 25 is 481. 481 minus 8 is 473. Whew! That's something. Holy cow. But there's my equation of a plane. You need a point and a normal vector. And since you need a normal vector and that's a perpendicular vector, you are going to often be doing cross products to get those lead coefficients for your planes, okay? Write both forms of the equation of a plane containing the line there and parallel to the other line. All right. So what that means is I want the equation of this plane. That plane contains, we'll call this line L1. Come on, L1. And that's going to be this line. And I want my plane to be parallel to this other line that's like up here. And I probably shouldn't draw it in the same direction as L1 because they're not the same direction. So let's draw it kind of like this. And we'll say L1 and L2 are skew. And I want the plane to be parallel to L2, but pass through or contain L1. Well, here's the thing. I still need a normal vector. And if L2 and L1 are in different planes, that means L2 and L1 are skew. So let's pretend for a second that I just drop L2 onto L1 and then I cross their vectors. I can find a vector that's perpendicular to both. Let's see if I can draw it. Yeah, it's doubtful, but we're going to find out. Oh, OneNote's doing that thing where it doesn't like me. Why? There we go. If I were to drop these together, I should be able to find something that is perpendicular to both of these by crossing the vectors from L1 and L2. So L1's vector is the vector 2, negative 7, 1. L2's vector is the vector 1, 5, negative 1. So if I cross them, L1 crossed with L2, see how they're kind of stacked already, kind of like a determinant? If it's okay with you guys, and let's face it, you can't really talk to me right now, so it's going to have to be okay. I'm going to do this without setting up the determinant and just kind of do it in my noggin. So L1 crossed with L2 is really going to be 7 minus 5, which is 2. The negation of negative 2 minus 1, which would be negative 3. So now it's really positive 3. And then 10 minus negative 7, which is 10 plus 7, which is 17. So that is going to be the normal vector for my plane. And since my plane needs to contain L1, my plane needs to contain any point from L1. Let's use L1's initial point, which is negative 3, 8, and 0. Negative 3, 8, and 0. So my plane is going to be 2x plus 3 plus 3y minus 8 plus 17z minus 0 equals 0. So this is 2x plus 6 plus 3y minus 24 plus 17z, which is 2x plus 3y plus 17z equals, let's see, positive 6 minus 24 is negative 18, but then I'm going to add it to both sides, so I get positive 18. And that is my equation for the plane. Nifty. All right. I'm curious how long this is. Give me a second here. How long is this video so far? Is it going to tell me? Come on. Yeah, it's only 9 minutes. I'm going to keep going. Now, the next part is to find the point of intersection of the line and the plane, or the line of intersection of the two planes. You know what? These take a little while. So I'm going to stop this video and just make it about setting up plane equations and then make another video about intersections. Sound good? Sounds good to me. All right, so now I need a bad joke. How do you fix a jack-o'-lantern? With a pumpkin patch. Did I use that joke with you guys already? I'm not sure. Just in case I did, because I can't remember. What do you get when you cross an apple with a shellfish? What do you get if you cross an apple and a shellfish? A crab apple. All right, now I'm done. I'll let you go, and I'm going to get back to my fire and probably make another video.